Hey, I'm Adam, and this is my charge tapes lab. The purpose is to approximate how much excess charge is on one piece of charge tape during the lab experiment. The experiment was that we started with a negatively charged piece of tape hanging, that's tape B in the picture in the bottom right, and then brought another negatively charged piece of tape, tape A, under the tape B until tape B moved from the electric charge. At this position, we measured the distance from tape A to tape B. Using this, we can find the amount of excess charge on one piece of tape during the lab experiment. So the whole system was tape B, and then surroundings was tape A. And then at the end of this experiment, we'll be able to know the number of excess electrons on one piece of tape. Some assumptions that we can make before starting this experiment is that each piece of tape has the same net charge. We can do this because both of the repelling forces are equal and opposite on each piece of tape, and we mainly do this because we really just want an approximation, and this is going to simplify our calculations a lot. The next thing is treat each tape as if the charge is located on a single point in the center of the tape, and this is going to really just simplify our calculations. Here's the model that I made with my code on the right, and it shows tape A and tape B. The red arrows are the repelling forces from the electrons, equal and opposite as shown, and the green forces are the force of gravity. So the force of gravity is going to be equal to the repelling force, hence tape B is not moving because the force is equal to 0. And then tape A is going to be held up by our hands. I didn't show the normal force because it wasn't really necessary. Here's some of the initial conditions and calculations that we did in our experiment. So our length of tape B was 21 centimeters, making the mass of tape B 0.21 grams. During our experiment, we noticed a separation distance of 2.5 centimeters when tape B started to move as we approached tape A to it. The force of gravity on tape B is going to end up being 0.02 newtons, and that's going to be equal to the force of from the electrons. So we can use this equation on the right. That force of gravity is just going to substitute for the force of electrons, and then we can solve for Q, and then we end up getting 1.19 times 10 to the negative 8 coulombs. And we divide that by 1.6 times 10 to the negative 19th, which is the charge of an electron, to get the total number of electrons that were transferred onto the piece of tape. Some other calculations that we can do with these numbers is find out the ratio of electrons transferred to the total number of atoms on the tape. So to do this, we found the length of our tape A, which is 14 centimeters, and then the area of the tape we found in meters, and then we know the area of one atom is 1 times 10 to the negative 20th. So we divide that, and we find that there's 1.778 times 10 to the 17th atoms on our piece of tape. So we divide these, and we get the ratio to end up being 4.35 times 10 to the negative 7 electrons per atom. That comes out to be approximately 1 electrons for every 2.3 million atoms on the piece of tape being transferred. Here's the code that I wrote in Python to make my model shown on the left. So at the top, I just wrote down all my constants that I kind of needed, and then I ended up doing my calculations so I could get the right magnitudes for my force arrows. And then at the bottom, it just shows me making the particles, making the arrows. Yeah, pretty much it. Some important questions that we have are: what if electrons had positive charges and protons had negative charges? What would change about the observations we made? This wouldn't really change anything because like charges still repel and different charges will still attract. And then next is, why is it important to handle the charge tapes as little as possible? What happens to the charge tapes as they come into contact with your hands? If the tapes come in contact too much with your hands, then the tapes will lose most of their charge. When they come into contact, charges are going to be transferred to reach equilibrium, resulting in charge leaving the tape and going to your hand. A big cause of error is going to be human error. This is mostly seen when measuring the separation distance between the tapes. When movement is seen, it was very difficult to get that accurate measurement, so we kind of approximated there. In conclusion, we approximately found that 7.47 times 10 to the 10th electrons were transferred to tape A. This allowed for a separation distance of 2.5 centimeters when tape B initially moved. With this experiment, we were allowed to see how transfer electrons can affect interactions between objects, which seemed to be a pretty cool thing in my opinion. And thank you for listening.